Alright, so for today I thought it might be an interesting idea to explore the PDF file format. And you know, first step would be to have a PDF file that contains only text, and let's try to have a C, you know, executable that is gonna take all the text from here and print it at standard output, right? And I've looked a bit into how to do this stuff, and at first I thought it's gonna be much simpler, but yeah, there's actually no, the text is not really, in plain text in the PDF file. You have to actually parse some binary data and convert it to, from binary data back to text. So that's quite interesting. And I've also found out that the PDF file format has a lot of like things inside of it, like Boolean, real numbers. That's quite interesting. It also has strings, dictionaries, which we might see, and then also streams. And the streams are the interesting part. They are like binary bits in the like binary chunks in the PDF file. So probably these are the important things, right? So let's try to create this PDF file. And yeah, I mean, I've already tested it, and I know that we'll need this dependency, the zlib library, to be able to decode streams. I guess because I'm using Nix OS, I'm using the flake just to make sure that everyone knows that zlib is a dependency. I hope that's enough. And the other thing that we'll need is actually a sample PDF file. So this is the sample PDF. It only has text. Maybe, we could in the future also do something like images. I think that's also quite interesting. And maybe, that trick of hiding data in PDF files. That could also be interesting to try and do, like hiding an executable in the PDF file. So yeah, but let's just create, like, install the dependency. So now we have the zlib library, and let's take a look at our sample PDF file, right? So as usual with any like file type, it starts off with a magic header, right? Like PDF, whatever. And then it has a list of things like objects. So here starts the object and then end object or whatever. Some of them, make kind of make sense. So we have a dictionary here and then a stream. And I've noticed that this is usually the pattern, like having this dictionary with length, flat decode, and then a stream. And yeah, also here. And yeah, it kind of repeats itself. So that's what I've noticed. And flat decode, if you Google it, you'll find out that it means that it was compressed with zlib. So I mean, it's flat decode, whatever. I don't know what it actually means, but it means that the stream data is compressed with zlib. So if we want to see what's inside, we have to use zlib to uncompress it. So that's what we are gonna try and do today. Basically, read the PDF file and then search for these kind of streams and try to flate, to uncompress them using zlib. So I think that's gonna be, interesting to try and do that. So let's start with the classic hello world. But actually we could as well just use ds.h just to make our life easier. ds.h, and we don't need that. Let's just do ds.log info. Hello world, like that. And then, yeah, to be able to use zlib, we have to link with z, but for now it's fine to just, yeah. Okay, so what we'll need from ds.h is gonna be dsio implementation. So we need to be able to read and write from files. Okay. And if we include zlib.h, I think, do I need to also, I guess, yeah. So now it also has zlib into this thing. We don't need it at first, but we'll need it to be able to decode stuff from the PDF file. So let's try to have something like a char pointer buffer is equal to null. So this is gonna be our binary data, and we are gonna use dsio read binary, and here let's say sample pdf and the address to buffer, and this function should return us the number of bytes that we read. That can be important, so say buffer length. All right, and obviously if we try to print that thing, it should work like at some extent, but yeah, the first 0 byte that we encounter is gonna stop it, so that's the only thing. But yeah, let's try to see what would happen if we take this chunk that's inside of stream and try to uncompress it with zlib. Let's try to see what happens then. So to be able to do that, let's do a small hack. So we're gonna have start index is equal to 0, and then for int I would like to have a loop that goes through each character and does a string compare, I guess, with the word stream. And once we find stream, it means that this thing starts. So that's how I would do it. So let's say I smaller than len, and then I plus plus, or plus plus I whatever. And here let's do a str and compare, because why not? It's better to do it sized in this case. Okay, with buffer plus I think that works, and it's 6 characters. So if this thing is equal to 0, it means that we found a start index is basically I plus 6, right? Because we want to jump over the word stream. Okay, and the next thing that we need is how many bytes we are gonna have. So stream len is gonna be 0 initially, and then for int I is equal to start index, I is smaller than buffer len I plus plus, and in here we have the word end stream. So if string and compare end stream with buffer plus I, and this thing has 9 characters. I mean, you can check it, like select the text and it should say here 9 characters, but I don't know for VS Code or other editors how it works. But yeah, if we find the word end stream, it means that end index is equal to I, right? I mean, let's just do something like this, and then the stream length should be, well, actually let's just keep end index and start index, right? So we know where the buffer, or I guess where the stream starts and where the stream ends, right? And here we don't have to do +9 because we found the first character. We might as well just do -1, but I mean, let's just think of it as it's end, but it's smaller, like it's a strict operation. It's not smaller or equal, so it works. Okay, so what next, right? We could extract a chunk. So if we imagine that we can do something like stream is equal to buffer start index until end index, like in Python, that's how we would do it, right? So we have the stream itself. So let's try to find how we uncompress things in zlib. So we have to do a byte f. What is a byte f? Now you might ask. Well, if we search for byte f, not sure what far does, like what you would use far for. I mean, it's nothing for now, but the byte is just an unsigned char, so that's, I mean, it's a char basically, right? So that's what a byte f is, and ulong f is just an unsigned long, so not that insane. So let's create a byte f source, pointer source, and this would be our stream. All right, so here I would say byte f pointer, and let's do buffer plus start index. So this is our source. It's a pointer that points to the start index. And what's funny is we don't care about the fact that we don't have an ending to this buffer, because we are going to use source length to indicate that, right? So that's pretty nice. So we need a ulong source len, and this thing is gonna be just, let's cast it still, I guess. Is gonna be end index minus start index. Okay, so we have these two here, and now we need so if we check the description of this function, it says that you need to allocate these things manually. So you somehow need to know how big the destination is, right? So that's a bit sucky, because the text that we uncompress is not gonna be the same size as source. It's gonna be something bigger. So we could say u long f dest len is gonna be source len times, I don't know, like 8. Yeah, I don't imagine it's gonna be bigger, so yeah. And then we have byte f pointer dest. We can just calloc it or something, size of byte f and dest len. And I guess what's pretty cool about this thing is that dest len is sent as a pointer, so we get back the actual size that was used. So you might as well just do free dest, right? And you know what I mean, realloc the actual size that you need instead of this full size. But yeah, so this thing is an integer. So let's just say result is equal to, oh, and the result is equal to 0. Yeah, so if the result is not equal to z, okay, then we dslog error failed to uncompress data, and then we have the error code, and then we can return the for person or something, and let's use our defer keyword. Okay, and let's try to run this thing. For now, I don't think. Well, that sucks. I thought it's gonna work first try because we are pretty cool, but I guess it didn't work first try. I mean, that's the usual stuff. It doesn't work first try, and I guess that's because maybe here we need to add another one. Oh my god, it's not that. I mean, maybe I can check with my implementation and see like how I did it first. Yes, something I think we need to do is also add a break here because we were just looking at the first one, so we don't care about the rest, we care only about the first one. Maybe that's the issue. Yeah, seems like that was the issue. So let's now do something like char pointer text, and let's cast our destination to text, and then let's try to dslog info, the extracted info is, maybe we can put like quotes around it, and then text, and let's try to see what we have here. So pretty interesting. We have some kind of text, but it also has like these garbage thingies, which I guess from my understanding these are like positions on the page where to write this text, and probably also like fonts and sizes of each character, something like that. But I see that the important text is in parentheses, so to be able to extract the important text, we just have to look for text that's inside parentheses, right? But no, we've come pretty far with this thing, and I was checking the entire text, and it looks like the first stream contains the entire text that's in the PDF file, so I'm not sure what the rest of the streams are for. Like this one is pretty huge, so what could be here? maybe it's some secret information that we could decode. I mean, we can check. So to be able to do that, I'd say we need some kind of for loop over all the streams. So we might have to change a bit our for loop here. So let's just do something like we have a for loop that goes from 0 to buffer length, right? And then we have this start index and potentially end index, right here. Then we do a string compare for stream, right? If we find the word stream, we get a start index. Maybe yeah, I was just thinking, okay, what about some kind of because yeah, another for loop would make sense here, like for, and then we just do I is less than buffer length. Right, so this would move I further and search for that word, and also break. And then we can do the same thing for this stuff. Right, but we don't initialize the I, we keep I the same because we want I to, you know, come here. I think that should be fair. Yeah. And then something like maybe if I is larger or greater than buffer length, we break, and otherwise we do this kind of stuff. So we put all of this here. Let's just remove all of this. Okay, so I guess if buffer is not null, we could free buffer. Maybe something here like buffer length is less than 0, log error, fail to read the file. Okay, let's just do small error checks. Here I would do continue rather than failing because we want to check each stream, but okay, fail to uncompress data, and maybe we can specify the start and end index just so we know what happened. We could also free that memory, so at the end we can free dest, right? Makes sense. We allocated this so we can free it. Okay. And then yeah, failed to uncompress data. Like start, or I guess, I don't know, %d, something like this. Start index and index. Maybe that's helpful. So let's try to recompile. Let's run it. So looks like the first chunk is done, right? But then we have 4 chunks that fail. That's quite interesting. So if we search for the word stream, we have it 5 times, right? So this one, this one, this one, this one, and this one. But it somehow looks like this one didn't really work, right? And neither this one. So I mean, I'm pretty curious what data was inside of them, because they still have this flat decode. But yeah, somehow it failed. So yeah, I mean, that's, I guess, interesting. But yeah, we actually managed to have something that gets text out of a PDF file. Sure, would be nicer to format it just like this, but I mean, I was curious what info was hidden in these chunks, but as that it says failed to uncompress data, so maybe it's either a different format, or I have no idea. Because I mean, it looks similar, right? It looks like it's this stuff. It even starts with the same character. So yeah, who knows what that data is actually. Maybe the length one does something. I guess filter is also in the first one, so that's not. Hmm. There's also this encoding, but I wouldn't say I mean, hmm. Yeah, quite strange. I mean, the indexing clearly is right, so we just get a -3 here. So let's try to check what -3 means, right? So actually, if we check for ZOK, -3 is data error. So it just didn't work to uncompress it. I mean, yeah, and wasn't like a memory issue, so times 8 here is fine, but yeah. And actually, if we do error checking, we should also free it here. Probably someone was yelling, but I've noticed it. Yeah, I mean, I guess we just cannot really uncompress that data for some reason, so I guess it is what it is. It isn't what it isn't. At least we got the text out of the PDF file. And sure, to get only the text, let's try to do that because probably that's a bit more interesting. Do we have the length? Yeah, we have this the length. Perfect. So instead of just printing this, let's just have something like int text len is going to be equal to this len. Let's use a j for the inner loop. J is smaller than text len j plus plus, right? So now we search for parentheses and we print until we find the closing parentheses. Or I guess the other option is to use a string builder. Let's use a string builder from ds.h. ds string builder. Let's have ds string builder. Let's call it, I don't know, string builder. Let's initialize our string builder, and now we can just, well, check if text len, I guess text is a parenthesis. So if text at j is a parenthesis, right? That was looking weird. It means that I guess while, well, 4 is probably easier to use here. Text len j plus plus. If text j is closing parenthesis, we break. So we have this for loop which advances until the closing parenthesis, right? And if it's not a closing parenthesis, then we can just string builder append character. See, like, somehow I thought about this like a while back. I mean, I think I needed append character at some point. So yeah, string builder, and we want to append text j character. Right. I mean, this thing can fail, but that's crazy. What? Oh yeah, makes sense, makes sense. I mean, it could fail, but probably we don't care about it. So we have, if we found this kind of parentheses, we should probably do j plus 1 first, right, to skip it. Then we have this inner for loop, and we search for closing parentheses. Yeah, makes sense. And we append everything between. I think that's fine. And then at the end we have char pointer text, obviously. Oh, plain text, I guess. I don't know. ds string builder build, and here is the address for plain text. Yeah, obviously this one can fail too, but there's loginfo extracted text is gonna be plain text. Oh my god. Yeah, I think that will be fine. So now we have extracted text, and then it says like sample blah blah, and it's the entire text. I mean, it doesn't have any, formatting. For example, this would be a title, I think. Sample PDF was like a title. It's like a subtitle or something. So yeah, I just imagine it does this, right? And it copies the text. But I think that's pretty nice. Yeah, again, I'm not sure why this one fails. I'll try to look into it myself. But probably it's like some probably data for Mac OS or something, because I see the entire text here, so what else could be here? Maybe a virus. I don't know. Yeah, like maybe data for Mac OS, if it's like Mac OS has special needs. Okay, so yeah, I guess that's all the stuff. So maybe, yeah, like error checking for that could be useful. Obviously, like a bit refactoring here because everything is in the main function, but that's something I don't really care about. Yeah, like this one shouldn't really fail if I think about it. Like in my ds.h implementation, maybe the way to do append character is to have on the string builder some kind of flag for failure. But yeah, like that would make your life much easier, because now we have to keep a failure flag here, and after the for loop is done we have to check it. But if the data structure itself keeps a failure flag, we can erase that error when we do build. Like somehow that makes sense, but I don't know, it doesn't matter. I mean, the only error that can happen here is you running out of memory. So I guess it is what it is. You cannot do anything about it. If you run out of memory, you run out of memory. But yeah, this one, can be kind of avoided. Actually, no, what the fuck am I saying? You cannot really avoid this error either. So if you get this error, you get this error. Again, it's probably memory issue. So if it's not 0, wait, 0 if it's successful. I mean, I don't know why I don't return the length actually, because I have items count here, but yeah, because yeah, I mean, it would make sense to return the items count, but no, it is what it is. So if it's not 0, then we can just zlog error, could not extract text. Obviously also free test and continue. Yeah, imagine like a continue defer keyword. That'd be the next defer. But yeah, I guess let's run again just to make sure that I didn't add a bug. Yeah, I guess that's working quite well, if you'd ask me. So yeah, hopefully this was also useful for you. Like, I guess, working with strings, this part, but maybe learning something new about the PDF format and how to like actually get information out of it. So these chunks actually contain some info. Maybe it also depends on each PDF file. Like maybe some PDF files have their strings in plain text, and I'd also be interested to see what happens if you have images in a PDF file. So yeah, but I mean, I have to look into that myself, see if it's interesting or if I know how to do it, and then yeah. But here it says usually large amount of data, so sounds like images to me from what I can hear. So yeah, I guess images in PDF files would be next. I guess hopefully this was also useful for you. So let's see each other in the next one.